Hello and welcome to SAT Prep video lesson number 19 on literal equations. So essentially these are equations that have various variables in them, and what you're going to do is just solve for one particular variable. All of our standard algebra rules apply, and like this says here under their example problems, these are all going to be math and science equations, many of which you probably have never seen before, but don't let that bother you. You treat it like any other algebraic problem, and you just got to use your rules of algebra. So in our first one here, you see how it gives us an equation, this equation S, and it says to solve for h. So we want to start to get h by itself. So the first thing I should do is subtract the 2 pi r squared over. Okay, so I'd have S minus 2 pi r squared equals 2 pi rh. Okay? And to get h by itself, I have to divide out that stuff that is left with it. So I would divide by 2 pi r because this is multiplication over here. So I have to undo the multiplication. So I would divide both sides by 2 pi r. So my equation would be S minus 2 pi r squared over 2 pi r equals h. And that is perfectly fine. But this could potentially be simplified, especially if it's a multiple choice question. It's going to be simplified maybe in a different manner. So let's practice that. So what we could do is we could actually split this into two fractions. So S over 2 pi r minus 2 pi r squared over 2 pi r equals h. So I just use a property of fractions to split the left side there into two separate fractions. And you'll notice when I do that, the 2 pi's cancel and these r's reduce. So I would have a S over 2 pi r minus what I had left was an r to the first equals h. So either this one or this one is acceptable. Just want to show you that extra step you could take if maybe the multiple choice options didn't match what you had gotten originally. All right, next one up. We've got this equation, p equals v squared over r, and we're going to solve for r. So if I have p equals v squared over r, all I have to do is multiply the r over, because right now I'm dividing by r. Okay, so I have to get this r to the other side, because if I'm going to solve for it, it can't be in my denominator. So I want to get it out of my denominator to start. So that would be p r equals v squared, and then from there divide by p to get r by itself. So r equals v squared over p. In this case, there's really nothing we can do to simplify this algebraically. Beyond this point, this would be done. Okay, we're going to skip number 3 actually, because we're going to do a problem in a minute here that's almost the exact same as this. It's just going to be a word problem form, but the steps algebraically will be the same. Okay, so we're going to skip example 3, and we're going to start practicing some SAT type practice problems. Now, one thing you will learn quickly with these kinds of questions is there's a lot of reading. And in the end, for all these examples, none of the wording really matters. Okay, if you look, it says, which of the following correctly expresses W in terms of P and L? Well, here's your function, okay, or your equation, P equals 2L plus 2W. And we're trying to basically solve for W. So solve for W. All right, well, I don't need any of the other wording in the problem. I don't need to worry about the fact that it's a contractor installing a fence. It doesn't affect how I solve this problem at all. So I would subtract 2L over. So that would get the 2W by itself. So P minus 2L equals 2W. And then from there, I would divide by 2. Now you have to divide the whole left side by 2. Now another way to do this, because this sometimes maybe is helpful for algebraic manipulation, is to multiply by a half. And here's why. You have to multiply the whole side by a half. Okay? And the reason I'm doing this is because it's going to get it into a form that looks more like one of the answers. If I distribute the 1/2, I get this. Okay? So you can see there our answer is going to be letter A. Now, if I treat it as division, like I was going to originally, it's the same thing. I just might not recognize it. So I would get this. So P minus 2L over 2 equals W. And then you got to do that little trick of splitting it into two fractions. And you get the same answer in the end. It works out to be the same thing, but remember, dividing by a number is the same as multiplying by the reciprocal. So here, if I multiply by a half, I can then just use my distributive property and see how this thing simplifies to one of those answers a little bit more quickly. Okay, number 2, again, long-winded problem. It talks about Coulomb's law. It talks about this, scientific notation, all this crazy stuff going on. But in the end, all we're doing is we're writing an expression for r squared in terms of the other variables. So basically solve for r squared. So if we have to start f equals k e q1 q2 over r squared. Now, do realize that subscripts, which are like these little numbers down here, are not like exponents at all, okay? In this case, q1 and q2 are entirely different variables. So I can't combine them, basically. I can't use properties of exponents to combine them, which is a common error, okay? So those are called subscripts. You can't combine those things anyway. Now, this k out front really just gets multiplied to the top. So f equals ke q1 q2 over r squared, okay? So if we want to get r squared by itself, and again, maybe I should go back and kind of describe why that happens. Ke, that's really ke over 1. And when you multiply fractions, you just multiply the numerators, multiply the denominators. Okay, so if we want to get r squared by itself, we have to first get r squared out of the denominator. So I multiply both sides by r squared. This is also technically cross-multiplying because it's f over 1. But I'm just going to treat it this way. So f, let me go back here. So I would get f r squared equals ke q1 q2, okay? And we're solving for r, so all I have to do now, we're solving for r squared, that is, all I have to do now is divide by f. So I would get my r squared by itself. So r squared equals k sub e q1 q2 over f. And there you go, you got your solution. The solution there is going to be letter D. All right, last one. So again, you've got all this stuff happening. Okay, now in this one, we actually are going to need the wording, and here you're going to see why. But you see how it says, which of the following expresses the number of successful attempts in terms of the other variables? Okay, so we have to read back through, which letter talks about the number of successful attempts. Well, successful sales attempts is S. Okay, so we're going to solve for S. So once we can go back and read through that and see that, all we're doing is solving for S. Again, all the other wording doesn't really matter that much, really at all, in solving this problem. So let's begin there. So R equals S over S plus F. Now this technique of solving this is a lot like the example 3 that we skipped, and this is why, because the technique is going to come up in this example here. But this is a really tough one, okay? So do you see how you have multiple S's? So because of that, we're going to have to somehow algebraically be able to get this down to only have one S. And if you think back to what you've been able to do in the past in algebra, if you have these expressions that have multiple S's or multiple X's, you could use factoring to factor out a GCF, a common term. And then you can only get one of them, basically. So we're going to utilize that, but we have to do some steps first. So the first thing I'm going to do is I'm going to multiply S plus F to the other side. Okay, I want to get rid of this one down here. So I'm going to have my R times S plus F equals just S. And now you see how the S is stuck inside the parentheses. I'm going to have to distribute now. So it's going to get actually more complicated looking before I can simplify. So I'm going to distribute the S, or the R that is. So I get RS plus RF equals S. The next step is I want to group. So I want to group the S terms. The S terms. So I need to get all the S stuff on one side. So I would subtract this RS over. So I would get RF equals S minus RS. And what that allows me to do now is, you see how I have these S expressions? I can factor out S. Not divide out, factor out. So I'm going to get RF equals S times, now be careful, when you factor this first expression, you have a 1 left. So 1 minus R. And now, because I've got just that singular S, and this is multiplication, I can divide both sides by 1 minus R. And these are going to cancel. Okay, so my solution is going to be S equals RF over 1 minus R. And that's going to be our answer, which it looks like we've got a solution up here of letter A. Okay, so that's how we get that one there, and that one's really sneaky. Good technique to know about the whole, grouping and then factoring when you have multiple terms that have that same variable that you're trying to solve for. Okay, so that's going to be it for this video. Thank you very much for watching. Okay, take care.